This week on Today in Space, space nerds leave Florida after they went to see a launch of Artemis II, now scrubbed until March, and cryogenic hydrogen did what it always does best, which is leak. Thanks for joining us. Let's dive in. Hello, everyone, and welcome back to Today in Space, the all things space science podcast. I have been in a content cave for the last few weeks since our last episode, and just preparing for the slated Artemis II launch, the first crewed flight to the moon since Apollo 17. I had to make the tough decision to not buy tickets to fly down to Florida to see that, but somewhere in my heart, in my gut, I had a feeling that Artemis II was going to be scrubbed during the wet dress rehearsal of SLS and the Orion capsule when it was stacked on launch pad. But what caused my gut reaction? Is it a lack of trust in NASA? No. Was it some cosmic coincidence and pure feeling and emotion that it would scrub? No. In fact, it was all based on a fundamental problem with liquid hydrogen, cryogenically cooled as a fuel source for rockets. First, let's take a step back in the Artemis timeline to 2022, 4 years ago. I was able to book time off from my corporate job to go down to Florida, stay at a friend's house on Merritt Island, and camp out for the maiden launch of SLS, Orion, and Artemis I. The first human-capable trip, although it was purely robotic, in lunar space since the Apollo era. I had a great time, met some really interesting people, and camped out on the causeway in my rented Tesla Model X all night, and had front row seat for NASA's massive rocket to take to the skies. Unfortunately, the launch would be scrubbed for the first time and then 2 times later as well, almost entirely due to hydrogen fueling issues. After trying to push my stay for a week and a half, it was time to come back home to Boston, and Artemis II wouldn't launch until November of that year. So, was my delay in buying tickets to travel down for Artemis II a trauma response from Artemis I? Kind of, but it was based in something more real than my hurt feelings after a triple scrub. To explain, let's do a quick history lesson on the Artemis program and the Space Launch System, or SLS. SLS is a very unique rocket system. It takes its design and many of the actual parts, from the main engines to the solid rocket boosters, from the Space Shuttle. In some ways, it's beautiful that the old, refurbished parts from the Space Shuttle are being repurposed instead of sitting in a warehouse gathering dust like the RS-25 engines were. In other ways, SLS is not reusable like we have the Falcon 9 and Blue Origin's New Glenn rocket, and so these historic reused vehicle parts from the Space Shuttle are actually being destroyed from flight instead of memorialized in a museum. But feelings aside, SLS is the Space Shuttle in many ways. Perhaps the most Space Shuttle thing about SLS is the use of its same main rocket propellant, liquid, cryogenically cooled hydrogen. But why hydrogen? Well, it's the smallest atomic element we know of, which means you can add a ton of fuel for use in launch. Hydrogen is also energetic, which means it's going to react well with its oxidizer, liquid oxygen, or LOX. It also means that a byproduct of combusting liquid hydrogen with liquid oxygen is H2O, or for the unscientific, water. So in a lot of ways, on paper, hydrogen makes a lot of sense to use as a rocket propellant when you're always trying to optimize your thrust to weight ratio and minimizing how heavy you are at launch versus how much fuel you want to have when you get to space. However, just like most things you learn in science, and more specifically engineering, things don't always work as well in reality as they do in theory. In fact, most of the time it doesn't. With that in mind, let's go back to the Artemis timeline, interconnected with the Space Shuttle timeline, to something called the Summer of Hydrogen in 1990, the same year I was born. That year, the Space Shuttle Columbia was struggling with hydrogen leaks, and after many attempts to resolve the leak, NASA decided to swap out Space Shuttle Columbia and bring out Atlantis to fuel her up and get back to the launch schedule. While the sight of 2 space shuttles passing in the night looks like it was an amazing thing to see in person, it would not actually be the solution to their hydrogen leaking problems. We covered this after I returned from Artemis I in 2022 and found a NASA employee report that outlined the issues with the Summer of Hydrogen. You can find the clip in the episode notes if you want to learn the whole story, but the long, short story was that the seal for the hydrogen fuel connection was not tested with hydrogen. It was actually tested with nitrogen, not the same particle size as hydrogen. In fact, a lot bigger. Hydrogen is so small that it can even leak through welds in metal, which is mind-blowing. And the supplier of this seal provided for the space shuttle was using nitrogen because over time, that testing center actually had a bunch of things like schools and more people around it. So they had to switch from the dangerously flammable hydrogen to something like nitrogen because they were so close to people they didn't want to, hurt other people. So it's kind of a good reason. But this oversight in testing and the incredibly fickle nature of liquid hydrogen led to many delays and, you guessed it, leak issues. So, after learning this 4 years ago, I committed that to memory. Alongside with my triple scrub trauma from Artemis I knew that with the cold temperature at the Cape, and the very first time that this SLS version and Orion would be stacked on the pad, there was a very high chance that the very fickle fuel source of liquid hydrogen would come back to cause delays. Did I feel good about not spending all that money for another scrub trauma in Florida? Yes, absolutely. But did it feel good to be right? Kind of. I mean, I know I felt bad for everyone who went down to Florida to catch the Artemis launch only to have it scrubbed. I know that feeling too well, so I definitely feel for them. But what I hope to leave you with in this episode is hydrogen-fueled rockets will naturally have a very high scrub to launch ratio. So expect to stay longer anytime it happens and maybe come back whenever they launch. Artemis II has launch windows in March and April right now, about 5 to 6 days every month for the rest of the year. And eventually, the NASA team for Artemis I figured out all the nuances. They were able to get the rocket fueled, replenish it, and then it performed the mission really well. I expect the same for Artemis II, especially since they made it much farther in wet dress rehearsal the first time than they did for Artemis I. So they are making progress. They also have a second brand new world record hydrogen sphere that holds all of that fuel, which means that they can attempt another launch within 24 hours, which back in 2022, when they only had one hydrogen sphere, it took 48 hours to refill that sphere. And that was getting all of those fuel suppliers to bring everything they had to load immediately. So really, in 2026, Artemis and the SLS are much more capable in its fueling abilities than they were before. But all we know is Artemis II is taking flight at some point this year, sooner or later. I'm excited by what I'm hearing from the team at NASA. The crew of 4 gets to spend some more time with their family out of quarantine before they go back in for the next launch attempt on their epic adventure to the moon. And we'll be here following along, and we hope you join too. So make sure you're subscribed to the podcast wherever you watch or listen. You can find all of our socials and links to the show in the link in our profile or by going to stan.store/AG3D Labs. You can also read the first part of our Artemis program series on Substack, where I go deeper into what Artemis is, in this first one, specifically the technology behind it, and why certain decisions were made, and how NASA rebuilt this return to the moon. You can follow us and subscribe for free or paid at todayinspace.substack for our journal, Making Sense of the Future. We're diving into all sorts of tech, from space to AI and 3D printing, and trying our best to make sense of how it will shape and change the future of humanity. And we love to see you there. Also, make sure to check out what we're up to at AG3D Labs. We have our first book in the editing phase. We're building an AI partner for 3D printing to help make anyone more successful and learn it quicker than you might do by taking a class or just watching YouTube videos alone. Make sure to sign up on our newsletter at ag3d-printing.com to stay up to date on that. And of course, if you have a 3D printing project and you need help or are dealing with a 3D printing challenge that's holding up your progress, go to stan.store/AG3D Labs and see our service options. We can jump on a video call same day for those big challenges, or help with a simple part problem, or maybe you're even trying to find your first 3D printer. Not to mention, our favorite new service is our Bring Your Idea into Reality 1-hour video call where we talk together, we take your idea, and we help make an actual 3D model of it in that hour. And after the call, we'll start up the 3D printers and send you a small sample part so that you can literally go from idea to part in hand after just an hour with us. There's a lot we can help with. So head over to stan.store/AG3D Labs to see how we can help you with 3D printing. Until the next episode, be well, stay curious, and don't forget to spread love and spread science. The world needs it.